Hey kids, welcome to lesson 9.3, Overriding Methods. Kids, the key to this lesson is understanding one thing. We can basically do three things with an object in Java. We can write a new method, which was pretty much chapters 1 through 9. We could inherit it, which was the first couple parts of this lesson. Or what we can do is override an existing method. Keep those three things in mind as we go along this lesson. A subclass inherits all public methods from its superclass, and these methods remain public in the subclass. But we also usually add more methods or instant variables to the subclass. Sometimes we want to modify existing inherited methods. Well, this is called overriding methods. Overriding an inherited method means providing a public method in a subclass with the same method signature. Method name, parameter type list, and return type is a public method in the superclass. The method in the subclass will be called instead of the method in the superclass. One common method that is overridden is the Tostring method. The example below shows a similar method called greet. In the following example, the mean greeter inherits the greet method from greeter, but then overrides it. We'll run the program to see what happens. Add another subclass called a Spanish greeter, or another language that you know, that extends greeter and overrides the greet method to return hola, or hi in another language, instead of hi. Create an object to test it out. Let's take a look at our code here. You can see we have a public class greeter and a public string greet, which is returning hi. Looks like we have a main method here. We're creating an object G1, and then we're printing off G1's greet. Then we're creating another G2, but that's mean greeter, which is referenced down here, and we're printing off that greet. Mean greeter down here is extending the greeter class up here. That means we're just overwriting the return method. Instead of it saying hi, it'll now say go away. And what we have to do is create another class, and this one is going to be called Spanish Greeter. We want it to say hola. What am I going to do? Well, let's come down here a little. And I'm going to make another class. This one is going to be called Spanish Greeter. And we're going to extend the greeter from above. We want to inherit all of those properties. We need to open up, and then we're going to do our Tostring method of public string, our greet. What is our greet? Well, it's going to return this time hola. Then we need to close this out. Don't forget that. And that should extend that class from above. We're not done yet. We have to create an object. So we're going to do greeter G3. And this is going to equal a new Spanish greeter. And then we want to print off the G3 greet. Now, when we hit save and run, we should get hi, go away, and hola. Well, let's see if I'm right, kids. Whoop. Looks like we have a spelling error. I have it down here as greater. Should be greeter, kids. And I did the same thing up here. Calling up to the must have great on my mind, kids, to do the return. Now we get hi, go away, hola. And this right here is just an example of how we override something. In this instance, it's overriding the string method here, greet. And instead of returning hi whenever we call greet, it's returning whatever that class is. For mean greeter, it's go away. For our Spanish greeter, it's hola. Just a good example of what overriding is. Note, to override an inherited method, the method in the child class must have the same name, parameter list, and return type, or a subclass of the return type as the parent method. Any method it is called must be defined with its own class or its superclass. You may see the @override annotation above a method. This is optional, but it provides an extra compiler check that you have matched the method signature correctly. And kids, I'm going to start adding this here. This is just a way for you to identify that you are overriding something. Don't get overriding a method confused with overloading a method. Overloading a method is when several methods have the same name, but the parameter types, order, or number are different. So with overriding, the method signatures will look identical, but they are in a different class. But in overloading, only the method names are identical and they have different parameters. Just keep that in mind. Here we have an example of overriding methods here. This is an object G2 greet, and it's just calling to whatever's there. And this one, it'll be calling Sam. In the example below, the greet string who method overloads the greet method of greeter. Notice that mean greeter inherits this method and it isn't overridden. In the example below, the greet string who method overloads the greet method of greeter. Notice that mean greeter inherits this method and it isn't overridden. After running the code, try overriding the greet string method in the mean greeter class to return go away plus the who string. Let's take a look at our code here. This looks like our code from above. We have our class greeter, our toString method greet. It's returning hi. We have a public string greet. The string is who. That will return hello plus who. Down here, we have our main method, G1's new greeter, G2 mean greeter, and we have Sam and Nimish. Down here, we're extending mean greeter, and we're returning go away. In this one, we should get hello Sam. In this one, we should get go away Nimish. The part replacing who is the overloading part right here. The overriding part is the greet part right here. Keep that in mind. Let's see if I'm right. Hello Sam. Hello Nimish. We got hello on both of them. Why is that? Well, if you look up here, we are just overriding this one right here, right? Greet, the one without the parameters. Remember, it has to be exact. That means when we come down here, what do we actually want to do? Well, greet down here is ultimately what's going to print off. What we want to do is override this. So we need to come down here and let's do our @override. And now let's put string who. Now when I hit save and run, I should be overriding this part and I should get hello Sam, go away Nimish. I'm getting an error here, and that is because this should be capitalized O. Also, looking up here, I have to override this as well. And kids, this up here says hello plus who. And right now I'm just returning go away. What I also need to do is to concatenate here, and I need to put that who the same as above. Now when I hit save and run, I should get hello Sam, go away Nimish. Again, we have to understand what we're overriding here, and what we're overriding is this part up here, and it has to be exact, kids. So remember, from above, everything that you write has to be exact. And down here is a good example of that. Keep that in mind. Also, remember the override has to be capitalized. If it is lowercase, it will give you an error. Keep that in mind moving forward. Note, to overload a method, the method must have the same name, but the parameter list must be different in some way. It can have a different number of parameters, different type of parameters, and or a different order of the parameter types. The return type can also be different. Which of the following declarations in student would correctly override the getFood method in person? Well, we have our public class person. It has a private string name, which is set to null. We have a class person, which is a string of a name. Name is set to the name. That's just setting it up there. We have a public string getFood. This returns hamburger. We have a public class student extends a person, so it is extending it down. We have two instance variables, ID and next ID. We have a public student string name. It is a name, an ID, and next ID. And then we have some return methods here, and returning the ID and setting the ID to the ID. And the question's asking, which of the following declarations in student would correctly override the getFood method in person? So what would override public string getFood, return hamburger? And remember, well, this is a subclass of this. Public void getFood. Well, is that how it's written? Nope. It's written as public string getFood. Does it have a parameter? No. So the only right one should be C. Which of the following declarations in person would correctly overload the getFood method in person? We have our public class person. We have a string name set to null. We have a class person. The name is set to the name. And we have a public string getFood returning hamburger. We have our public class student extending person. So they're getting all of these plus an ID and the next ID. And we have all that stuff down here. The same as above. And which of the following declarations in person would correctly overload the getFood method? Well, in here, we have our public string getFood. We have to overwrite what's in there. This is the main class, right? We come down here. We have public void getFood. That's a return. We don't want that. Public string getFood. And then we have some quantity. Well, for overloading, you must change the parameter list somehow, the name, the type, or the order of the parameter. So that seems right. And then we have a public string getFood. So I think it's a B because that's what it's been teaching us all lesson, kids. Inherited getSet methods. Inheritance means that an object of the child class automatically includes the object instance variables and methods defined in the parent class. But if the inherited instance variables are private, which they should be, the child class should not directly access them using the dot notation. The child class can use public accessors, also called the greeters or get methods, kids, which are methods that get instance variable values, and public mutators, often called the modifier methods or setters or set methods, which sets their values. For example, if a parent has a private instance variable name, then the parent typically provides a public getName method, and a public setName method is shown below. In the setName method below, the code checks if the pass string is null before it sets it and returns true if the set was successful or false otherwise. The employee class inherits the name field but must use the public method getName and setName to access it. And this is demonstrating the inherited getSet methods. Let's take a look at it, kids. We have our class person. They have a string name. We have a public string getName that's returning the name. We have a Boolean setName, or the new name. And if the new name is not null, well, then this name equals the new name, return true, otherwise return false. So it's adding names. Public class employee extends person, so we're getting all those things down here. And this one also has next ID and ID. And the ID equal next ID and next ID plus plus. We have a public get ID that returns the ID. And if you come down here, we're creating a new object employee called imp. And it's a new employee. And we're going to set the name is Dina. Well, then we're going to print off get the name. And then we're going to print off get the ID. The name should be Dina. The ID should be 1. Well, let's see if I'm right, kids. Dina and 1. And this is just showing you how we're getting access to those public and private variables. Given the following class definitions, which of the following would not compile if it was used in place of the missing code in the main method? We have a class item. It has an instance variable x. Set x is the new x. X equals the new x. We have a public class enhanced item that extends item. So it's getting all this stuff plus y, and y setting y equals y. Then we're creating a new object in here under enhanced item. It's called current item. So what's it asking again? Given the following class definition, which of the following would not compile if it was used in place of the code segment? So which one of these would not compile? Well, if we come down here and we go to current item set x, well, that's going to work because we inherit the public set x method from that item. So it's getting extended down. And the same thing is going to happen with the y method. Current item equals 3. Well, if we come up here, and you can see, well, we're in this class enhanced item here. So we have access to this private variable here, but we don't have access to this private x variable up here. And because we don't have access to that, that's not going to compile. We have a programming challenge, pet sounds. The following pet class keeps track of a pet's name and type and has a constructor, get method, and method called speak that prints an animal noise. We got a couple things to do. Write a subclass called dog that inherits from pet. Write a dog constructor that has one argument, the name, and calls the superconstructor passing it the name and the animal type dog. Override the method speak in the dog class to print out a barking sound like woof. Do not override the get method. This superclass method should work for all subclasses. Uncomment the dog object in the main method to test it out. And write a similar cat class that inherits from pet and has similar constructors with type cat and overrides the method speak with a meow. Woo, this sounds like a lot, kids. We have a public class pet. It has 2 instance variables, a name and type. It has two constructors, n and t. N is going to be equal to name. T is going to be equal to type. We have two string methods, get type, get name, and that's returning the type and the name. We have a public void speak. Right now it's printing off grrr. And we're creating a new pet here. And remember, in the pet class, new pet P is Sammy and hamster. We're going to print out get type, and then we are going to do P speak. Well, what should happen, kids? Since I'm getting the type and speak for P, I should get hamster and grrr. Let's see if I'm right. We have hamster and grrr. We come down here, we have some stuff we have to uncomment after we complete a dog and cat class. Well, let's go down what we have to do here. Well, the first thing is write a subclass called dog that inherits from pet. That's pretty easy, kids. We can just come over here and we can go class dog extends pet. Well, the next part is we have to write a, let's shrink this down so we can see this. Write a dog constructor that has one argument, the name, and it calls this super constructor passing the name and the animal type dog. Come down here, we have to write our constructor. So we're going to do our dog, and it has to be a string with a name on it. We want to do the super, and super is going to be the name because that's what we want to inherit, and it's going to be a dog. Then we have to override the method speak in the dog class to print off a barking sound. And what we're going to do is we have to make a new public void, because if you look up here, kids, what we're just doing is overriding this. And remember, it's got to be all the same. Public void speak. And in this one, we're going to do system and we're going to do woof like that. Should be 2 over there, I believe. That is everything for them. And let's uncomment. And we're going to have to keep some of this here, kids, because we haven't made a cat yet. So let's comment that out. Now, this is going to be our test dog. And this is eventually going to be our test cat here. When I go to hit print, I should get hamster grr still. But now I should get dog because I'm getting get type, and speak should get woof. Well, let's see if that's what happens. Looks like I have a spelling error here. Ooh. Kids, wasn't a spelling error. We just had one too many semicolons. Now we get hamster, grr, dog, woof. That looks like that's working for our dog. Let's go ahead and do the same thing for the cat. So we're going to do class cat, and this is extends pet just like above. And let's keep this here so we can see what we're doing. Let's just drop this down a little. And this first thing we have to do is our constructor. So public cat string name, no semicolon this time. What are we overriding? Well, all the name and dog. Next, we have to override the speak. And this one is going to be system. And a cat makes meow. Like that. Clean up our code a little here. And that looks like we got the right amount of curly cues. Now I should get hamster grr. And kids, I don't know what hamster makes that noise. Dog woof. And then cat meow. So we're just overriding what kind of animal it is, not the actual name of the dog. Let's hit save and run. Oh, you know what we forgot to do? We forgot to uncomment our cat objects. Let's go ahead now and see what happens with Fluffy. Uh-oh. I bet you I put dog again for the cat class. Let's write cat right there, kids. And now we have cat meow. And there is how we override our method speak and inherit from our pet class. Pretty neat, kids. Oh, we're getting an error up here, kids. That's because we didn't put an exclamation point in this one. Now if we hit save and run, we have to be a lowercase c here. Now we should get all of our greens. There we are. Just be aware of that if you're getting a red on the first one. We have our summary. Method overriding occurs when a public method in a subclass has the same method signature as a public method in the superclass. Any method that is called must be defined with its own class or its superclass. A subclass is usually designed to have modified, overridden, or additional methods or instance variables. A subclass will inherit all public methods from this superclass. For example, all the set and get methods. These methods remain public in the subclass. Overloading a method is when several methods have the same name, but the parameter types, order, or number are different. And hopefully you found this video helpful, kids, and you understand what overriding is a little better. As always, if you have any questions, come see me. Otherwise, I'll see you on the next video. See you later, kids. Bye. Bye.